Hi, Alex Williams of the New Stack here today with Casey West of Pivotal. Hey, Casey.
Hello.
Casey today is going to show us a few things. First, he's going to show us a developer-centric look at Cloud Foundry and how it can be used by developers on a day-to-day basis. He's also going to do a demo for how to deploy Docker in the Cloud Foundry ecosystem. And then he's going to have a little surprise for us. And so we'll save that one for later. But Casey, good to have you here. Tell us a little bit about yourself and what you do over at Pivotal.
Sure, thanks. Yeah, I'm on the outbound team at Pivotal for advocacy and outreach. So although my career has been about 16 years of building software, mostly on internet infrastructure and security, I decided about 6 months ago to join Pivotal and start spreading the good news about what it's like to have and use and operate Cloud Foundry. So that's what I do over there. My title is Principal Technologist for Cloud Foundry.
Well, excellent. So why don't we get right into the demo?
Yeah, so we'll start by examining our gem file here, a typical way to look at our vendor dependencies in Ruby. We're going to see that we're going to use a relatively modern Ruby version, 2.2.3. Puma is a web server that will actually negotiate the web requests for us, and then some basic Sinatra libraries. So the first thing I want to do is jump right in and show you the app. Again, very, very simple here. We have some basic requires of Sinatra. We're going to bind to it the IP address that says we can talk from any incoming request. That's a special 0.0.0.0. And then here's a demonstration of one of the tenets of a 12-factor application, or an application that we like to refer to as being cloud native, which is to get configuration information from the environment. In this case, we're going to get our port number from the environment. And that's something that Cloud Foundry will provide to you. So when Cloud Foundry spins up an instance of your application, it provides a dynamic port for you to bind to. And as long as you're listening on that port for incoming requests and sending your output in the same way, then you'll be able to negotiate network communication for your application. Then we have one very simple thing that we do here, which is when we call this web service at the root, we will return a small amount of JSON, indicated by the JSON keyword here. And it will be a key of instance, and then the value will be another environment variable. CF instance index is an environment variable that Cloud Foundry also provides you to give you information about which instance number you're running. So when you spin up an application, you might begin with one instance, but that's not very scalable. It's not very high availability, and it certainly won't let you do a lot of concurrency in your application. So as you spin up and scale out, horizontally scale, we call that, you'll spin up new instances, and each of them will have a unique index. This will allow us just to see that everything is up and running and working properly. So this is a basic API, and I think that what we should do now is probably go ahead and deploy it. So to do that, there is a command line utility that's part of Cloud Foundry called CF. And when you first attempt to use CF, you get a lot of helpful information because there's an incredible amount that you can do with this command line utility. It's written in Go. It's easy to download. You can get it off of GitHub. I should actually pause here for a moment and just let you know, Alex, that everything I'm showing you here today is actually all open source Cloud Foundry. So if you wanted to download and get up and running an instance of Cloud Foundry, whether it was on your laptop, like I'm doing here for demonstration purposes, or in AWS, everything that you'll see today is actually fully open source, and you can do it without talking to a vendor. But if you wanted to, we're always here.
So tell us where people can get access to the free version of Cloud Foundry.
Yeah, so the place to start really is cloudfoundry.org. So for folks who might not be familiar with the Cloud Foundry ecosystem, there is a foundation that owns the IP, the intellectual property of all of the Cloud Foundry core. And the development that happens on Cloud Foundry on a day-to-day basis is provided primarily by members of this foundation. And that includes companies such as Pivotal, IBM, HP, and many others. And then some of these companies, including the ones I just mentioned, are also vendors that provide commercial distributions if you wanted to take advantage of additional functionality they may bring to the table. But you can start here, and you can also go to github.com/Cloud Foundry. And that's a place where you can find many repositories that comprise the entirety of Cloud Foundry. The two that I would say to look at if we're going to highlight any would be the CLI, which will be the command line utility that you'll see me use. That's our primary interface to interacting with the Cloud Foundry platform. And the other one would be CF Release. CF Release brings together all of these components into a release that gets updated every week. It's got a Cloud Foundry has a very tight and consistent update cycle, and you can actually see that when you go to see all of the tags for releases. Every single week, a new release is cut with whatever is stable and ready to go. It's a very mature continuous delivery model. So we're up to version 2.2.7, and I think there are more than 100 releases just on GitHub here from the last couple of years. So that would be where I would go to check it out. Okay. So I mentioned that CF is our primary interface to interacting with the platform. I want to show a couple of quick commands. CF apps can describe the apps that we have running. I do have a couple running as backups just in case live demos don't work out the way that I hope they would. Let me actually make this a little bigger so we can see it. So this describes the applications that we have running. Now, I am in my CFENV directory. This has my application that we just looked at. In fact, if I look at app.rb, we'll see the same thing that we saw in our text editor. And the way to deploy an application in Cloud Foundry, the only thing that you really need to do on a typical basis is do a CF push. So I will do that now. And while that's happening, I want to take a look at the manifest. You'll see here at the top it says that it's using a manifest file in this current directory. And I want to open that up and describe that a little bit. Cloud Foundry, like many other systems, uses a manifest to describe some basic operating expectations for an application. So it's a YAML file, and you can see that we list an application called CFENV. A basic memory expectation. This is actually a constraint, and this constraint goes all the way down into the container layer because every application that runs in Cloud Foundry is running in a container, and those Linux containers are to be able to isolate and constrain the resources used by a given instance of an application.
And the YAML file is almost like the contract, isn't it? It basically describes everything, so so the developer knows exactly what to do. It seems to be becoming a hallmark of what we're seeing with new microservices architectures as well.
That's right. That's right. And actually, you can also compose a series of applications here that should all be spun up together, which is very similar to a Docker Compose, which has the same kind of qualities in terms of its descriptiveness. Absolutely.
Yeah.
Yeah, so we have an application up and running. And what this did is it actually built a container using the Ruby build pack. And the build pack describes all of the vendor libraries and software that needs to be laid down on a base operating system in order to run this application. So it knew that it was a Ruby app, and it also installed all of the gems, which is that vendor management component. It added our application into the container. And then once we had that container, which we call a droplet within the Cloud Foundry ecosystem, then we were able to actually get that droplet up and running. So we wanted to start one instance, and we knew that we were going to run a Ruby command in order to do that. And now we have an instance running. So what we can do, we could certainly go to this instance in our web browser, and we'll see it here. It's a relatively unexciting demo in this way. I can also curl it if we want to, and this will come in handy later. And we'll see that we have instance 0. One of the first things that I always like to do as a developer is to see what happens when I have a few instances. I found that the majority of problems that developers face when they're getting into the notion of distributed or parallel workloads, those issues arise whenever you go from one instance to 2. But if you already have 2 instances and you can get to 3 or 300, usually you don't really see the same types of problems. these are usually problems that manifest from not having a 12-factor app. And just for completeness here, it's always good to point out that there's an excellent website called 12factor.net, which describes a series of constraints that you might adhere to as an application developer in order to reap benefits of platforms like Cloud Foundry. It was actually written by the Heroku team, and it was for their platform in particular, but these are very universal and generally considered to be best practices in the industry. So for any developer who hasn't read through this, there's a lot of great writing here on this site, so I highly recommend it. But why don't we go ahead and scale an app? So we've pushed an app. We can see that it's running. And scaling, we'll go to two instances, for example, is also very simple. You just use a cf scale command, and then we have a couple of instances. And we'll actually take a look at that by using the cf app command. Cf app will give us some basic operating information for the application that we request. In this case, it's the cfenv app. We can see that we have two instances running. And I think that we can actually test that out in a couple of ways. One way would be to come to our web browser here and reload a few times. And you can see that our instance number changed from 0 to 1. So we're actually round robin getting routed to each of our instances as we go through and reload. We can also use curl on the command line, for example. So we'll use a simple while loop, and we can see that as we make requests, we get different instance numbers. Another important aspect of running in a distributed environment for developers is being able to get at logs. If you can't read your logs easily, especially among a plethora of potential instances, then it becomes really challenging to debug problems, whether they're in production or in a staging environment or what have you. So we have a solution for that in Cloud Foundry as well.
So how do you monitor those logs? Is this what you're going to show?
Well, so I'm going to demonstrate a particular aspect of that. There are a couple of things when it comes to monitoring within distributed systems, but one of them, which Cloud Foundry does take care of for you, is the aggregation of those logs to be able to get a single stream of logs from a multitude of instances. So what we're seeing here is streaming of HTTP request logs. This is what Sinatra spits out on standard out and standard error. And we're seeing that live as we make requests here on the left side. To your point, Alex, it's important to note that Cloud Foundry does not have a built-in log analysis or monitoring tool system. But because the streaming output is aggregated, you're able to submit that to something like Splunk or your in-house Elk stack or a Graphite system if you want. And you can do that monitoring analysis on your own, but that is one of those places where the line is pretty clear between what Cloud Foundry does for you as a platform and what you have to bring up to support, your monitoring operations.
That's a good delineation.
Yeah, I think so. And it's also important to know that Cloud Foundry itself, as a platform, of course, it's a collection of software, and it's a distributed system all on its own, and it has its own logging fire hose, if you will, for all events that happen in Cloud Foundry, which you can also send those out to your logging system. But that's at the operator level, and that's not quite as applicable to your everyday developer.
This gets to the heart, of what I'm familiar with about Cloud Foundry, and that it's opinionated for a reason, right? There's, you do want to have those different capabilities baked in, but you have to have constraints too. So it makes sense then to constrain kind of the capabilities of the application and know what it's good at.
Right. Yeah. I mean, the constraints allow Cloud Foundry to keep promises for you. And as a developer, what you want to do is be able to iterate quickly and reduce your risk. And if you adhere to the constraints that Cloud Foundry asks of you as a developer, you actually increase the power and the effectiveness and the resilience of your software. So there are some clear upsides, but there's no doubt about it that you have to be willing to accept the opinions of the platform as your own in a way.
Yeah.
And that can be challenging at times. It's especially challenging for teams with existing software, especially larger teams or legacy software where they want to get them running on a modern platform like Cloud Foundry. It can take some effort to retrofit, or there's a term that's used these days, forklift your application into the cloud. And so it's again, I think important to note that you'll have to do some work there, but it's often worth it in the long run.
Mm-hmm.
So we have an application running. It doesn't do a whole lot, and I think that after you get a prototype out the door, the next thing you do is start fleshing it out. And so I like to say from here that what I'm going to do is create more enterprise grade functionality for this application. It's a little bit tongue in cheek, and you'll see why. But I'm going to check out a branch called Enterprise Features, and we're going to take a look at this. Very few applications that you run in complete isolation. And in fact, most applications have to interact with some dependent system, and that's often a data storage system. And so in this case, for the purposes of this nice simple demonstration, we're going to include Redis, and we're going to use Redis in order to do some basic analytics. So we are also using a gem called CF App Utils, which in the Ruby ecosystem is actually a nice way of interacting with backing services and auto discovery information for connecting to those services. And we'll see that in the app here. So the app has changed a little bit. It's actually a little bit longer. We have a class called Analytics. And I think that, as long as you add analytics to something, you can call it enterprise grade is the joke that I go with. But we need to create a Redis connection. And in order to do that, we need to get credentials information. This also demonstrates another aspect of a fully featured platform, which is there will be a Redis running which this application can connect to. But in order to understand its hostname, port, password, other types of credentials, you don't want developers hard coding that into their application, and you don't want them necessarily putting it in revision control. We've all probably either been there or had a colleague who's been there when they've unintentionally committed an AWS key to their GitHub repo, for example, which is a sad day for everyone when you realize that, yeah, you're paying for Bitcoin mining and you're not even getting any of the profit. But so this class will attempt to get credential information off of the environment, and the way that it'll do that is with the CF app credentials. Under the hood, what's actually happening here is that there's an environment variable provided by Cloud Foundry called VCAP services. And this is actually a JSON payload describing any backing services that you have bound to this application. And we'll go through and show you how to do that in a second. But if there are any for Redis, and they have these tags, so for Redis and within Pivotal, then we will go ahead and get that information and provide it to Redis. If there aren't any, then we'll just go with the default. And in this case, this happens to be a Redis URL environment variable that the library will read, which is a pretty common thing across all Redis libraries in almost every programming language and environment. And that can be helpful for local development if you weren't running this on the platform, but today we are. So we can just base this on the platform. And then we have a method called visit. And what this is going to do is increment the number of visits we get. So we're using very modern technology to implement a 1997 era visit counter CGI, but bear with me. So we've updated our JSON payload.
Not everything is brand new, right?
That's right. Everything that's old is new again.
That's right.
So our JSON payload will have an instance as we saw before. But it'll also list the visits. Now, this will demonstrate nicely a horizontally scaled application bound to a central data store, and the fact that the stateful information that you're sending to that data store remains stateful across all instances. So, if we want to deploy this, we actually have a little bit of groundwork to lay. One of the things that I think is really interesting about the Cloud Foundry platform is that it's broken out into two primary layers. There's Cloud Foundry, which is very application-centric, and we've been interacting with that a bunch. And then underneath of Cloud Foundry is an infrastructure automation and lifecycle management tool called Bosch.
Mm-hmm.
And you can go to Bosch, I believe it's bosch.org or bosch.io. You can go to bosch.io to learn more about Bosch. This is also a fundamental part of the Cloud Foundry ecosystem, so it's also operated by the foundation. And the thing about Bosch is that you can release many things to it. We release Cloud Foundry to it. That's actually what the CF release repository is that I pointed you to earlier. But we can also release things like Redis. And we're able to do that in a relatively high availability way and with auto provisioning, which is what I've done here. The way that as a developer I can understand what services are available to me to provision and use is to use CF Marketplace. So we have a marketplace. In this case, my marketplace only has an instance of Redis because this is a small environment I've set up for this purpose. In a more fully featured Cloud Foundry environment, you'll actually see the ability to auto provision things like Redis, MySQL, RabbitMQ, Postgres, Cassandra, many other things that you might need to take advantage of. There's Hadoop and monitoring information for Hystrix within the Spring ecosystem, that sort of thing. And so what we're going to do is create a service instance. So what we can see here is that we have the ability to create Redis instances, but we don't have any Redis instances. And we can actually demonstrate that with the CF services. There are no services which have been created. But in order for this application to work, we need an instance of Redis, so we'll create one. And we'll use the create service command. We want to create a service, and it will be a type of pRedis. And the plan that I'm going to use is a shared VM. You can do shared or dedicated. The distinction here is quite literal in that a dedicated Redis instance will use Bosch to auto-provision a new virtual machine running Redis, and the only thing that will run on it will be your version of Redis. Shared will run multiple isolated instances of Redis on a single virtual machine. So that really is the distinction. We need to give it a name, so I'll call it CFENV Redis because it is the backing service for the CFENV application. Now, we have a service, and we'll look at our list here. This is another interesting application for Cloud Foundry, which is that just because you have a service doesn't mean an application can speak to it. You have to explicitly allow an application to talk to a service, and you do that through a binding mechanism. Conceptually, this is similar to the idea of localized networks of pods in Kubernetes. However, architecturally and the way that workloads are laid out within Cloud Foundry, it's not the same. But again, from a developer-centric point of view, you can think about it in a similar way.
What are the distinctions that would be of note for a developer?
The distinctions between the two, you mean?
Yeah, just some of the few.
Yeah, I think from a developer's perspective, there aren't a lot of differences that you actually need to pay attention to. I think the differences are primarily on the operator side. The plan of how to distribute work across a cluster of compute resources is something that should be left as an exercise to the platform. It's not something a developer should really worry about too much. And I think it's accurate to say that the plan that Cloud Foundry has is typically to co-locate the pool of resources for application instances for Cloud Foundry within one section, and then your backing services typically are provisioned in separate sets of virtual machines. So you don't quite have the locality that you get from Kubernetes, which is more of an operational distinction. But from a developer point of view, as long as you're practicing reasonable practices around service discovery, you shouldn't really see a lot of difference. So let's go ahead and bind this service to the application, which we just did there. And we give this helpful tip that in order to inject information onto the environment for running instances about our new backing service, we do have to restage or restart that service, because environment variable information is only provided at startup time, and then it's immutable. And another key aspect of this to know is that what we've done is we've created a service through what we refer to as a broker. And that broker means that there's a Redis instance and there's an application, and in between the two is this binding, and that binding actually manages the credentials, and it keeps those credentials encrypted at rest, and it keeps them. It auto creates them, it generates them, and manages them itself. So the broker is actually responsible for the authentication information between the service and the application. And when you restart the application, any bound applications, the broker will provide that information to the application at that time. Now, what I'm going to do is just push a new version of the app, because I have this this more enterprise grade version here ready to go. I'm doing this manually, but I think it's important to take a step back and recognize that the actual deployments that I'm doing here manually for demonstration should be done by something like Travis or Jenkins or another CI tool. You should let your robots do this typically. You wouldn't be doing it manually. But if you're just playing around, if you have a developer, sort of sandbox area, then it's more than fine to be doing this manually. And so what we have here is we restarted our application. We still have 2 instances. Let's scale it up a little bit for fun to 4, we'll say. And I need to remember the CF at the beginning of that command. Mm-hmm. And I think what we'll do is continue to tail the logs while doing a little bit of a loop here, and we'll see what we get. So what we can see here is that while our instances are variable, where Cloud Foundry provides a router internally which automatically does load balancing for us, so we don't have to actually configure anything when it comes to routing requests to however many instances we have. But you can see that our stateful information about our visits keep incrementing, so that's pretty helpful. And then, of course, if we were in an actual browser, we can see similar things happening here. So that's pretty handy. So that would be what it's like to sort of do typical development and pushing things to Cloud Foundry. Some of the highlights here are that you can scale up your instances to respond to your incoming workload or your incoming requests load without having to reconfigure firewalls or load balancers or anything like that. That's pretty helpful. You can aggregate your logs to see what's going on there. These errors are because I don't have a humans.txt or robots.txt file, and that's what Chrome expects all the time. And also the auto provisioning, not only of being able to spin up the instances and get a URL for them, make them routable, but also be able to spin up services that back your applications relatively painlessly, and then connect them to your application. So I think that's a pretty decent demonstration of typical work. Now, the thing that I think we could move on to, if you like, is there's some new work. It's still considered beta, but I have it operating on my instance here to be able to spin up applications that are actual Docker containers. Mm-hmm. So it might be nice to take a look at that and see what that workflow would look like. I mentioned before that the applications that I'm running now are running in containers. There's a key difference between the Cloud Foundry ecosystem and the cycle of building that artifact, the image in the Docker world, and then shipping it around and spinning it up. In Cloud Foundry, you do a CF push, and Cloud Foundry as a platform behind the scenes, it spins up a task to create a container for you and wrap all that up, make it immutable, put it in a place where within the platform it can be shipped around and spun up as needed. Okay. Within the Docker ecosystem, you're typically a little more hands-on in building a container pushing it into a registry or a repository, and then writing some automation or using tools like Kubernetes or Docker Swarm to pull them out and spin them up on your compute resources. So I think that the primary difference here, and one of the things to keep in mind, is who is responsible for building that artifact and maintaining it, which is very similar to the Docker model is very similar to your operating system model with app repositories or RPMs in the Red Hat world. Someone is building a package, putting it into a central repository so that it can be pulled down and installed in a distributed environment. So the Cloud Foundry ecosystem being relatively self-contained, the Docker ecosystem operates in a different model, and that's something to note. But when it comes to actually running the containers and the benefits that you might get from a platform like Cloud Foundry, the workflow is actually very, very similar, and you get a lot of the same benefits. So I think that might be worth taking a look at.
Okay.
So this application that I have here, I'll actually go back to my non-enterprise grade version, and there is a Docker file which I want to look at here. So I've built a Docker container for this application. And this is an example of the work that you would do in order to put together a typical Docker container. And I've already built it, and it's probably not worth our time to rebuild on the show here. But I'll just run through it really quickly. I start from Alpine Linux, which is gaining a lot of traction these days.
It's gaining a lot of traction, isn't it?
It is. Very lightweight, very security focused. And so it creates containers that are much smaller, which just simply makes them easier to ship around and easier to manage. So when you see a command like apk, if you're familiar with apt-get, for example, you'll find apk update would be similar to apt-get update, and similarly for installs. But in any case, we'll just run through this very quickly. We set a Ruby version, and all of this work here is to install that version of Ruby, which is a bunch of work that you have to do, and similar down here. And then you also have to install Bundler, which is what provides the gem file vendor management, and configure Bundler appropriately. And then you can add the application and run bundle install, which installs all of the vendor libraries, and then provide it an entry point for actually running the application. So this is a pretty lightweight Docker file. Folks who are familiar with building Docker containers who are using them, say, in production or as a major part of their ecosystem, would be quick to rightly point out that the bulk of this work would be done to create a base Docker image, like a base Ruby image, for example. And then this entire Docker file would be much smaller. But for the purposes of the demonstration, I think it's worth at least seeing the work that goes into building a container from scratch, right? So there are ways to manage this that are a little more robust, especially if you're doing a lot of work with containers. I think an important thing to point out here is that there's a lot of similarity, because all containers are Linux containers at the end of the day. They're a series of Linux kernel constraints wrapped around a file system. And what Cloud Foundry does with their build pack model is very similar to what we see here in this Docker file, which is that we start from a base file system, in our case here, Alpine Linux. We install all of our vendor information into the container on that file system. That's what the build pack is primarily responsible for. And then we add our application and we explain how to run it. Almost identical, frankly, to the way that Cloud Foundry builds containers. The key technical difference is that we use a different file system format. So the Docker file system is a layered file system, whereas the Cloud Foundry file system is kind of comprised of two layers, a read-only layer, and then what you have for adding your application. But those differences aside, it's interesting to note that the way that you build containers, almost no matter what format you're using, is pretty much the same. So this would build a Docker container, and you can actually, if you felt like it, you could go to Docker Hub and take a look at this. You can play with it if you want to, but I have a container called cfenv-docker. And there are a couple of tags which actually just follow the Git branches that we're using today for this demo, master and enterprise features. But we can take a look at this and give it a shot at installing it. So to deploy a Docker container, you do need a recent version of the Elastic Runtime for Cloud Foundry, which is called Diego. A couple of months ago, it was released with Docker support, and you have to enable a feature flag to get that running. You can see your feature flags with CF feature flags
Tell us a little bit about Diego for people who may not be familiar with it.
Oh yeah, sure. So when Cloud Foundry was first released, the original scheduler was called DEA. We had a whole theme around law enforcement when it came to operating workloads and managing their constraints and making sure that they were within their constraints. So we had this concept of a DEA, and because developers are fantastic at naming things, when we went to rewrite that and we rewrote it in Go, we decided to name it Diego, and that's just what we did. But Diego is the version 2 of Cloud Foundry's Elastic Runtime. It also rebuilt our API for running and managing workloads or containers, which we call Garden. Our format for containers is referred to as the Warden format. Warden has been around for at least 4 years, so it does predate Docker as a format for containers, which doesn't make it better or worse or anything. It just
predates it.
Just has been around for a while.
Yeah.
And so this rewrite was a rewrite to Go, which had certain operational benefits. It was much faster, for example, and that was helpful, easier to build and maintain. But Diego operates similar to many other workload schedulers. It can do long-running tasks like server-based work, and it can also do short-running tasks like administration.
But it's called Diego because it's Diego, and it's written in Go, right?
That's right. Yeah. So it has almost all of the same operational properties whenever we're thinking about a developer-centric view, but it was built with a few key benefits, and one of them was this pluggable architecture for running containers called Garden. So with Garden, one of the interesting things that we get from Diego is that we're able to run Garden Linux containers, and that can run Warden containers or Docker containers. And because it's all plugged into Cloud Foundry, that means that you can orchestrate workloads, which could be Diego or could be Warden-based containers that are built with build packs, or Docker-based containers built in a Docker ecosystem format. You can orchestrate those and manage them and admin them from a single platform. So that's a really interesting capability. We were actually able to extend that working with HP and Microsoft to get workload orchestration on Windows of .NET applications.
Oh.
So in addition to that, when we think about this pluggable interface, there's a project called Garden Windows that allows you to do .NET apps. Now in Windows 2012, Microsoft is very clear, and we're very clear to note that you should not do multi-tenant capabilities whenever you're trying to orchestrate .NET apps on Windows, because while you do have some ability to do some process isolation in Windows 2012, it isn't universally secure. So you want to be orchestrating workloads that are in friendly environments. So that means, don't run your public paths doing this or anything yet. Windows 2016 will not only have much better container support as part of the Windows 2016 kernel, but also Docker is working heavily with Microsoft as well. So we'll see Docker as a native capability in Windows. So that's pretty fantastic. So that's the primary benefit that we get out of Diego, is the idea that within any heterogeneous architecture, and most architectures at any level of scale, especially in enterprise environments, are often heterogeneous. You've got everything from Java to Go to .NET, laying around somewhere, and the idea that you could actually manage them all from a single platform is pretty thought-provoking, and I think pretty powerful. So that's one of the things we get from Diego. So we have these feature flags, and you do have to enable the Diego Docker feature flag right now. It isn't on by default. This will change over the coming months, but as it's still in beta, we're still ironing out some of the kinks. But I want to show you anyway. So the way that we deploy a Docker container, and I'll just for review, I'll show you the apps that we have running. I do have a couple running as backups, but I want to deploy a fresh version. It's very similar to the way we deployed CFENV. And I'm just going to go to my home directory, for example, because I was in that source code directory, and I just don't want it to muddy the waters of this demonstration. But we're going to go ahead and do a CF push. We do need a command line flag, Docker image, and I'm going to provide the information from the public Docker repo that I have up there, kcwest/cfenv docker, and I want to deploy the Docker tag master in particular. And the only other thing I really have to do here is provide the name of this application, which will also provide an automatic domain name for me. So this should be all we need to do to deploy a new version of this application, but it'll be a version that was built as a Docker container. It does a lot of the same things that we saw from the build pack model, except that it doesn't need to use a build pack in order to build a container. What it does is it still creates a container, and this is a technical nuance which I will explain. So we have a running instance, by the way.
So build pack versus container, are there use cases that apply to either one? Can you use just both for whatever environment you want what you're building in? Is there distinctions that you guys are thinking about here?
Yeah, I think so. So for most applications that you're building, if you're the developer or the development team for an application, I think it's important to say that the container format that you're using, if you're going to use containers in order to build immutable artifacts that can be that can be spun up in a platform, it's really inconsequential. It's not consequential that you're using the Docker format or the Warden format or whatever format comes out in 6 months, because there will probably be a new one. I think what is consequential, though, is what sort of supporting infrastructure you have to manage the running instances of those containers, to be able to make it easy for you to not only develop but operate your application, keep it up and running and healthy over the long haul. And so when right now, I know well, actually about a year ago, it was very fashionable to talk about the container format and to get everything into containers. And as long as you had a container, it seemed like everything was going to be all right. And these days, I think the same types of conversation are happening around the scheduler space, because there's a lot more choice, a lot more projects coming up and getting mature and actually being used in production. You've got Kubernetes, you've got Nomad, you've got Docker Swarm, Mesosphere, does a good job with Marathon, or Twitter's stuff with Aurora, and all of these choices, and all of them are really getting battle tested. I think that's really where a lot of the mind share is at right now, and they're talking about that problem. Yeah. Cloud Foundry has an answer to that problem in its scheduler with Diego, but then adds a bunch of additional things, and this is what we sometimes refer to as, or I like to refer to as, a minimum viable platform. The idea that there's a certain number of operational characteristics your production environment needs to exhibit in order for you to be able to maintain a distributed system at scale. So you do need a scheduler. You need something that's going to do automatic health checks and failure recovery. You need log aggregation. You need a dynamic router and load balancer. You need something to be able to manage and distribute those immutable artifacts, whether they're Docker containers or droplets in the Cloud Foundry ecosystem. And you need service discovery and automatic service provisioning. And I think if you have these things, then you've got a pretty mature operational model for managing a complex architecture. I think I answered your question by taking it to a slightly different level, but I think it's important to say that having a container doesn't solve a lot of your problems, but what you have to actually manage it and manage that application and scale it and keep it healthy is much more valuable, and I think a more important conversation to be having.
Yeah, it's a progression that we are definitely observing, in our own research of of the ecosystem, and just the container format itself, has value, but there's really, now we're looking at building blocks more than anything for how you're building out these modern applications, so they can be, flexible, and you can use them, you can develop them for, business needs that may change, or new features you may want to provide.
Right, absolutely, and I do think that right now, while you said it before, Cloud Foundry is very opinionated, and if you are willing to adopt our opinions as your own, then you get a lot of benefits out of using Cloud Foundry. It's all of those building blocks put together in a way that works day to day. But there's still a lot of value and a lot of excitement around collecting those building blocks and putting them together on your own. Right. And certainly there are some ways that makes it better. Now, when it comes to whether or not in Cloud Foundry you would run a Docker container versus running a build pack based container inside of the platform, like I said, most of the time that doesn't really matter. One of the things that I hear a lot when I talk to folks about Cloud Foundry and about Docker support is the idea of not wanting to be locked in, not having vendor lock-in. So if I can build a Docker container, if I can run it in Cloud Foundry, or I can run it in Docker Swarm or in Kubernetes, then that makes me feel a little bit safer about the idea that I'm not putting all of my eggs in the Cloud Foundry basket in case I don't like all of the opinions of Cloud Foundry. Now, I would argue that the work that you do on your application within its architecture to make it capable of running in a container in the first place, running in a healthy way in a container, that's that 12-factor cloud native application model. All of that work is the actual hard work of getting an application to run in a platform or on a distributed scheduler. And if you've already done that work, whether or not you're doing a CF push and letting the build packs build your container, or whether or not you're running a Docker build, that's a minuscule amount of work to go from one to the other. So I often have to remind folks that the actual legwork that they've done is in making a cloud native application in the first place, or potentially refactoring an existing application to be cloud native.
I had a conversation with Cote as part of this, this series of discussions we're having with you guys. And he also made the point that, what you're trying to do is differentiate the application itself, right? So that's where your time and energy really should go, in differentiating the application.
Yeah, I often ask folks who want to, build a great platform inside of their own company. I ask them what do you want to be the best in the world at, right? Is your company, is your organization, or your software, is it building the next great platform, or is it building the next great, Uber or whatever it is that you're up to? And if it is a platform, that's great. And maybe you'll join Pivotal or IBM or Google in their effort someday. But chances are the thing that differentiates you and makes your business great doesn't have anything to do with that. Right.
Most people are just building software, right? They're wanting to do something that makes what they do unique.
That's right. Now, I think the important thing is that you want something that is going to work and let you sleep at night and feel comfortable and feel like you're not at risk. And so as long as you, whether or not you're taking those Lego pieces and putting them together yourself with an unstructured platform approach, or you're using something like Cloud Foundry, as long as it works every day and you can focus on the task at hand at that differentiating value that you're creating, I think that's where you get a lot of benefit. So what we have here, just to jump back to this a little bit, is we do have an application running that is a Docker container. There's a technical detail that I think is important in our current implementation. It doesn't matter for the typical developer, but people are often interested in hearing, well, how are you actually running the Docker containers? We're not running the Docker daemon as you might typically run on a virtual machine. Part of that is that daemon is a potential single point of failure that you have to monitor and keep up and running. And if the daemon goes down, all instances become unreachable. And that's a a concern that we really didn't want to have to deal with. So going back to what is a container, it's a series of metadata about Linux kernel constraints wrapped around a file system. You can also unwrap that. So the approach that we've taken is to actually unwrap a Docker container and convert it into a Warden container. Because we've been running Warden containers in production and at scale very successfully for years and years. That was the approach we took today. Pivotal and many of the foundation members, the Cloud Foundry Foundation members, are also members of the OCI, the Open Container Initiative, which is where Docker placed in public trust the intellectual property around Docker's core capabilities and format. Mm-hmm. And one of the things to come out of the OCI that is really fantastic is Run C, which is a much more lightweight, stripped down, and no daemon is required for Run C to run a container. And we are moving our Linux-based container support for both Warden and Docker containers to using Run C under the hood. So that is in active development within Cloud Foundry's ecosystem right now. I'm not sure when it'll be done, but the development is at least progressing, and that's a cool thing to look out for in the future. Yeah. But as far as we're concerned, we have an application running, and we have an instance of it, and it is a Docker container-based application. And we can do the same sorts of things that we did before. It operates almost the same way. So CF scale, for example, to get a couple of instances running, we can do that. And we can take a look at the operational characteristics here with the CF app command. So we do have a couple of instances running. We should be able to demonstrate that with a simple while loop like we did before. Instead of hitting the original application, we want to hit the application that is hosted at cf-docker. And we can see a similar thing. We cycle through the instances. It's up to you. If we wanted to, we could also bind Redis to the enterprise grade version of the Docker container, but I think that what you're going to find is that because the workflow is so similar, it will seem like we're retreading the same water that we already saw. The only difference really is that you use a command line flag for a Docker image to push the app, and otherwise the workflow is the same.
Well, I want to get to the surprise.
Oh yeah, sure. So,
but are we? I don't want to rush things though. Do we have it? Is there anything else you'd like to show here?
No, I think this is good. These are your basic commands and everyday activities that you would do if you were operating, if you were working with Cloud Foundry to develop and deploy software. So that's really what I wanted to show.
Great.
So I think my surprise is somewhat topical. I don't know how many people who would listen to this show have been keeping track of the last 15 years of language development in the world, but this past Christmas, so roughly maybe 2 weeks ago, the Perl 6 programming language released its first version. It's been in active development for 15 years. Incidentally, basically since the beginning of my career, and I started my career as a Perl developer. So that's a pretty exciting development. And Perl 6 being a brand new language, brand new to the world in terms of its first 1.0 release, which they named 6.c, which frankly I don't know why, but Larry Wall has always been kind of a jokester, so no one ever knows. So what I wanted to show you is actually getting a Perl 6 application running on Cloud Foundry, because why not get the most modern language, or at least most recently released new programming language running on a modern platform. So we can do that. So I've created a port of this very small application called CFENB to Perl 6. And let's just take a look at what we have here. I'm going to stash those changes. Let's take a look at what an application in Perl 6 looks like. So we have, in Ruby land, we have the gem file, which provides information about vendor libraries we're going to be using. And in Perl 6, there's a meta.info, which is actually a JSON format file. In this case, for our meta.info, we have an application named CFENB Perl 6. And it depends on Bailador, which I am not a very good Spanish speaker, but this is a Spanish word for dance
Cool.
or dancer. And what's interesting about that, to walk this back in the etymology, is that in Perl 5, there is a lightweight web framework called Dancer, which is based on a lot of the principles of Sinatra. So we kind of go back there. So the Ruby work inspired the Perl work. And what I actually find fascinating about this in general is how often within programming language communities you get this cyclic effect of things in Perl or some other programming language influencing, say, Ruby, and then Ruby influencing Perl, and vice versa. That's pretty neat. And we'll also use a JSON library called JSON Fast because we want to produce a JSON API. So this very basic application uses Perl 6 and this Bailador library. It gets information about which port to bind to off of the environment, and this is the Perl 6 syntax for getting information from the environment hash. We call it hash in the Perl community. Some programming languages call it a dictionary, for example, or an associative array. So when we get the base URL for this API, we'll set the content type to application JSON. We will get instance information again off of the environment, or we'll just specify it as none. And then we'll return JSON here, and it'll again be this instance with instance ID. So this is a very basic app. We also have our manifest.yaml because we're going to use a build pack to build. I had to jump through a few hoops here. I'm not really willing to say that this is enterprise grade because while I'm using a build pack that is for Rakuda, which is the interpreter for Perl 6, or it's the code name, if you will, for the interpreter for Perl 6. I'm using this build pack, but I actually had to build a custom image whenever I first did this of Perl itself, Perl 6 itself. So I have to provide a few environment variables. The build pack will use these environment variables to understand which version to get. And I happen to be hosting that on Dropbox because it's what I did at the time. Mm-hmm. So don't run this in production.
Okay.
Yeah, so we'll go ahead and push this app and see what happens. Maybe we'll get Perl 6 running in production here. So we have a similar model to everything else. It reads the manifest, figures out what build pack it's going to use, and starts building a container. Uploads our app source files, and so now we're getting our binary of a pre-built Perl 6 distribution. And we'll see whether or not it will download our dependencies and get them running. All right, so getting close. Mm-hmm. Yeah, so Perl 6 is an interesting language, probably not ready for prime time in most organizations, but here we go. We have an instance, and let's see if we can do horizontal scalability of a Perl 6 application on Cloud Foundry. And we'll just see what's going on here. So we have 3 instances. So one thing about Perl 6 at the moment, and it is a young language, is that it uses about 10 times as much memory as your typical Perl 5 or Ruby application, but they'll work on that. So we'll go ahead and tail the log file here just to see what that looks like. But
so you're a longtime Perl user. What do you find exciting about Perl 6? I mean, it's new. What is it about though, in Perl 6 that you're finding?
Yeah, so I'm tinkering around with it. It is true that I've been using Perl in my career for a very long time, and I've followed along with the Perl 6 development. Right now I'm tinkering with it, and I don't think it's quite ready for typical business use cases, but it does have a few key things that for language design I think are really interesting. One of them is a grammar's syntax. So Perl has always made a name for itself for being a text processing language and having very powerful regular expressions. It's a double-edged sword because people often look at Perl source code and say that it's the old joke is that it's a write-only language, that you can't read the source code because it's so difficult to read. And I'll agree that I've probably written my fair share of Perl that is impossible to read. But the grammars actually make it so that you can write very sophisticated parsers to do domain-specific languages or to parse rather complicated incoming text streams, and I think that's going to be very powerful. Interesting. And so the syntax there is definitely something to go and check out. There's also a lot of functional programming and higher order programming concepts built into Perl 6. It borrows from everything from Smalltalk and Haskell to Ruby. Well, Ruby borrowed from Smalltalk as well. But I think that they've done a really good job of building a language where you can do some pretty complicated functional programming techniques in order to cut down on the amount of source code you have to write to do rather complex workloads. But I will say that the syntax is still something that I'm learning when it comes to that, because it can be terse. But that's kind of the appeal for Perl developers. Yeah, so we have the logs that are streaming, and we are seeing instance changes here. So we do have Perl 6 running on a platform. I'd like to believe that this is the first instance of Perl 6 running on a modern scheduler and a modern platform. So I'm kind of proud of that, even though it's just for fun.
Excellent. Well, we'll definitely highlight that.
Cool. Well, I think that's what I had to show for you today. That, as I said, is a very developer workflow-centric view of what it would be like to operate with a platform and some of the capabilities that you get from things like Cloud Foundry.
Well, Casey, thank you so much for taking some time to go through what it's like for a developer to use Cloud Foundry on a day-to-day basis, showing us a bit about Docker and its and how it's used in Cloud Foundry, and a first-time look at Perl 6 and in a scaled-out environment. Congratulations on that, right there.
Thank you very much.
Great.
Yeah, it was a lot of fun.
Yeah, that was a lot of fun. Thanks a lot, and we'll talk to you soon.
All right, take care.
Bye-bye.